Welcome to the second video in Section 3, Sending Messages via Routers. In the previous video, we discussed the difference between actor reference, actor path, and actor selection. In this video, we will take a look at how to implement the router actor based on our current knowledge of Akka and router types. We will then implement some routing strategies that come with Akka, such as random router. And finally, we will introduce other routing strategies in Akka. Let's start coding then. First, let's take a look at the worker actor. This actor handles only work messages. Now let's think about the implementation of the router actor. This actor should contain a list of workers, known as its routees. So let's add pre-start method and create 5 instances. When a router receives a work message, it selects the routee and forwards the message for it. It will select a random actor from routees. Forward message means that the original sender reference is maintained, even though the message is going through a mediator, like a router. In the app project, we create the router instance and send to it 3 messages. Let's run the app and check our printing messages. Excellent! Our router is working. In our implementation, router actor is the parent for routees. This is called pool. We have another type of router, which is a group. That means routees are created externally to the router, and the router sends messages to the specified path using an actor selection. Now, let's implement group router. The group router takes the routees list on the constructor, receives implementations such as router pool, except for instances where we need to use actor selection to forward the message to it. In app object, we created 5 worker instances. Then we created the list which contains paths for actor instances. Our instances were created under our system actor, so the path for worker 1, for example, will be /user/w1. Then we create the router group instance. Let's run and check our printing messages. Good. Our implementation is good, but this implementation will produce a bottleneck in our app. So Akka provides specific implementation for router actor and comes with several useful routing strategies right out of the box. In Akka, we can define the router actor in configuration or in the code. Let's start implementing random router. First, we implement random pool in a configuration. In a configuration file, we add this configuration. Random router pool is the name of the actor. And this contains 2 variables, router type and number of instances. In the app object, we will create a router instance instead of props. We will use fromconfig.props that takes props of routee actor. Let's send 4 messages to the router. Now, let's run the app and check the printing messages. Excellent! Let's create a random group router in the code. Like the previous router group, we'll create 3 workers and define a path list. To define the router, we will use the actor of method that takes props for the random group router and sends 4 messages to the router. Let's run the app and check printing messages. Excellent! I think now the definition of the router is a simple task. Let's quickly check out the other routing strategies in Akka. Round robin. Routes in a round robin fashion to its routees, and you can check an example in our source code. Balancing. A router that will try to redistribute work from busy routees to idle routees. All routees share the same mailbox, which means all routees will be on the same physical machine because they physically share the same mailbox. Smallest mailbox. Forwards the message to routees with the fewest messages in the mailbox. Broadcast. Forwards the message to all its routees. Scatter, gather, first completed. Will send the message to all its routes, then waits for the first reply it gets back. This result will be sent back to the original sender. Other replies are discarded. Consistent hashing uses consistent hashing to select a routee. Tail chopping is like scattergather, but sends a message to one routee, randomly picked, and then after a small delay, sends the message to the second one, and so on. It allows sending the same work to more workers if it seems as if the first one is not going to respond in time, and therefore, one can get way better latencies on responses sometimes. To summarize, we discussed routing strategies in Akka, and we implemented Random Router. You learn more about routing right here. See you in the next video. Replace actor behavior via become, unbecome. Join me there.